What's up, everybody? We're going to be starting our part 2 of quantum mechanics. There's a 2 for you, in which we're going to be discussing something a little bit different today. We're going to be talking about electrostatics with the salt cows. Now, are we all familiar with salt cows? They're sort of round, spherical objects that they come in two varieties. They come in the positive variety, like this, and the evil twin, the negative variety. So what are these salt cows going to be doing? Well, today they're going to be throwing a wrench into the normal operation and understanding of the electrostatics. Now, what's the problem we're going to be considering today? Well, we're going to start with a long, some would say golf club-like object here, and it's going to be dotted with negative charges. No, 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 no. Okay, everybody seeing that fine? Looks a little, the blur edge, it's adjusting, there it is. Okay, so we have this golf club-like object. It's very densely populated with negative charges. So we want to find the electrostatics here. The most interesting object that we can look for to start off is the electric potential, which I'm going to call something economics. Some type of economics. Does anybody know what type of economics? Okay, that's right. And we want to know what that is surrounding this golf club-like mysterious shape. So we're going to write down the equation. Remember the names of the equations. This is going to be Poisson's equation. Poisson. Okay, moving on. So we have upside down triangle of the V equals the rho divided by the epsilon. Epsilon is a Greek letter. It could also be written like a dish, something like dish. And what is this upside down triangle, you might say? Well, just because you asked, we're doubling down. There, we just did it. That's a 2. Everybody familiar with 2? Remember, this is part 2, so we're doubling. Okay, never mind. Upside down triangle. What does that mean? Well, let's say that we're in XYZ coordinate, which we're not, but let's say we are. This means to take the derivative with respect to the variables, okay, like a dish, and then you add them together in different directions, or maybe you don't add them together. Now I think this is correct, and this is what the triangle essentially tells you to do, is some procedure like this. If that doesn't mean nothing to you, then you do not consider. Okay, returning back to the Poisson. Oh look, the wrench is there now. Okay, so we have the two epsilons. They're actually the same. This is a material property. It's a material property, okay? We can have various different materials. That's what's floating out here. If this is air, it's a small number. If this is styrofoam, I don't know what it is. We're actually going to pretend that we're in water, because that's where the salt cows live. So that it's got to get a little baby W, just like that. This one can have it too. Little baby W, like the W? Oh yeah. So the W is just in water, okay? In that case, this has a number value of about 80. Remember our discussion of numbers last time? This is a number, just like the other ones, except it has a particular value. And this rho is the charge. That's the charges that are going to create the potential and interact with it. And these charges, where do they come from, you ask? The salt cows. It comes from the salt cows. So we're going to be interested in where these salt cows want to hang out. So if you excuse me, we're going to move to the next page. Very good. Equals 1. And this salt cal, Zi equals -1. All right? So we can say that this rho value, this charge density, is equal to the exponential of minus E times the potential of the KBT. And then we're going to do minus, which is from this negative short cal, E to the positive, because it cancels with the negative sign that's already in there. E to the positive, the potential, divided by the KBT. Now, does this sort of exponential remind anyone of anything? That's right. It reminds us of the sinh function. Now, do we know why it's called sinh? I don't know, because there should really be an S there. So then you could call it cinch, but there's no S there. This H here stands for hyperbolic. Hyperbolic, yeah, we're not going to talk about why it's called this. But going back to our original constraint, and knowing that there's actually a 1/2 involved in the cinch function, we can finally write down the equation. So doubling down on the upside down triangle of the V, we're going to introduce a factor of 2 that we didn't have before. We're going to put on the fundamental charge that we have right there. And we're going to put down the constant C infinity that I dropped from previously. And we're going to divide by the epsilon, we'll do this one now, of water. And we're going to multiply by the cinch of the fundamental charge over the potential divided by the kBt. And that, boys and girls, is our to the positive ones, because these two guys are going to have that electrostatic sort of Coulombic interaction that we're really familiar with. But at a small level, how does this really work? Well, I'll show you.
Any other questions?